Hello everyone! Chapter 3, video 4. This is Miss Osier.
And Miss LaHart.
And let's use some exponential growth and decay real life examples.
Real life examples. Now this is just breaking it down. Remember, if you have an exponential function, you can either have an exponential growth, which means your b value is bigger than 1.
Oh, look at that.
Yep, look at that pretty graph. And then you have exponential decay where your b value is from 0 to 1, which means pretty much a fraction or decimal.
So it's going to be decaying because it will be going down by whatever that fraction is in an exponential rate.
Now, you all love these equations back in Algebra 2. Just kidding. But guess what? You have to have them again, and you have to memorize them.
Okay, so let's be clear here. This is not that bad, okay? It's simply increasing by the rate, decreasing by the rate. This is just the basic one. So this is when everything's pretty and it matches. Do not overthink this. 1 is the 100% that you already have. If you're increasing, you're getting more than 100%. If you're decreasing, you're getting less than 100%. So the 1 almost represents like 100%. But in a formula, we don't use 100. We use 1 because we do the decimal of the percent. Down here, if you ever see the words compounding continuously, we'll say PERT. P times E, remember E is a number, to the RT. When I say E is a number, I literally mean it is a actual number, like pi.
Yep.
It's not a variable, it's an actual pi. Now, for the middle one, it's going to seem like this because it's not going to have these buzzwords. But the thing that's going to be different, it's going to say like it has an annual interest of 5%, but it's compounded quarterly. So I have an annual or yearly interest, but it's compounded quarterly. Those don't match. So we use this function to adjust for the number of times, how often it's compounded.
Quarterly, monthly, weekly.
Boom.
And you'll have to remember those 3 formulas on your exam.
They're not that hard.
So look it up. All right, so you're going to get a lot of word problems with this chapter. Just deal with it. So we have a population of town is decreasing by 4% and started with 12,500 residents. Which of the following is projected population in 10 years?
Okay, so it's just, this is basic because we're not being told any sort of compounding other than just the fact that it's decreasing by 4% per year. So 1 minus 0.04.
You fill in all the values,
Cetera,
you do the math, and then you make sense of it. So this is a population. So does it make sense to have 0.4 of a person?
No.
Don't be coy and be like, yes.
No, it does
Round
not.
to the smart value.
Yes.
Common sense.
Be smart. Use common sense.
Holy lot of words. Just deal with it. Let's see what we got. We got stock price of wind power increases at a rate of 4% per week. Its initial value was 20% or $20 per share. On the other hand, we have Gerbil Energy is crashing. Losing value at a rate of 11% per week. If it's a price of $120 per share when Windex was 20, after how many weeks will the stock be the same?
Okay,
Model them
so
with equations.
let's be honest. Like, I don't just read through a word problem and I'm like, clearly I can do this entire thing without reading this again. I would realize that I need right now a % increase, and I would probably set up both of those equations to start and solve them. Okay? Then I might keep reading like, oh, I don't know necessarily how to solve this. I'm not sure what I'm looking for. So then I would keep reading, and they want to know when it's the same. So then I would grab my graphing calculator, graph those bad boys or girls,
and see where they intersect. And knowing that W represents weeks, and in this case, like our W is our X, it's our variable, it's this thing that's changing. So when we get a solution of 11.5 comma 31.4, what does that mean? At 11.5 weeks, they will be equivalent at $31.40
per share.
Per share.
Okay. And remember, in the calculator, you can't use W. You have to use X.
Oh, yeah, that's a good one.
Seth is a very lucky young man whose parents gave him $5,000 to invest for his 16th birthday. All right, he's got 2 investment options. One's at 4.5% interest, and the other one's at 4 6/10% interest. But they're compounded differently. The first is compounded annually, so remember that's matching, whereas the second is compounded quarterly, so that's when we need to use the other formula. So the first example, you're using the basic formula. The second example, you have to account for the compounding 4 times per year. So that initial interest rate is being divided into 4, and then it's happening at 4 different times per the year.
The reason why we use the basic formula on the first one, because remember, annually means 1 time a year, so if it's compounding once, you're gonna,
divide by 1 times 1, you don't need it there.
Right, so that's why that one. So we did that, and then we plugged in to see where these both would be at 6 years. And then, although it's still more, which one? We got B.
B.
So it's compounding quarterly. It will get you more money.
More money.
That's, pretty good.
I mean, it's like $67 more roughly. But
that's money you didn't have.
Exactly. And you might be like, well, of course, it's a higher percent interest. Sometimes a lower percent, like, it depends. So you really want to check.
Plan B.
Plan B.
That's it.
Have a great day, everybody. We will see you in class.